So now we just put our Arduino Nano clone on the breadboard. We just need the software. We go to Arduino.cc and download the Integrated Developing Environment IDE. We can download the old one, Arduino 1.0.6, or the newer one is okay. So here is the old one. We just select which Arduino Nano with Atmega 328, and we select an example. And you see there are so many examples here, but we choose a basic one, the blink one, because we don't need any extra hardware for this, because it uses an onboard LED for showing some blinking. And what's doing this hardware? First, we need to install the software for interfaces with our Arduino Nano. This is on the Arduino Nano there is a chip that converts from the USB to the serial. So you can choose Windows, Linux, or Mac OS X. You can see Windows is much newer than Linux, that's very ancient, and Mac OS X. If you have a clone system or its dubious origin, you have to be careful to download the Windows one, the latest driver, because many clone chips are using a counterfeit FTDI chip that will disable not really permanently, but if you don't know how to fix it, basically it's permanently, will disable the chip from further use, basically rendering your $10 Arduino clone board useless. So if you are on Windows and you have an Arduino clone, I suggest you to get the older version and don't get it from Windows Update, because Windows Update has the newer version. So here it is. This is just a driver for let your computer see the USB to serial converter that is on the Arduino Nano board. Now I will describe what this code will do. If I press load, I select the port, so USB serial, after I install the driver, and it's done. And before showing you with a camera what's going on the board, I teach you what this code is doing. Here in the setup loop, setup routine is started the first, and they just initialize the digital pin 13 as an output. As you can see, pin mode 13 output. And then there is this loop that will run forever. And what is all do is digital write 13 high. 13 is my LED pin. High, it turn on the pin. And then wait for 1 second, 1000 milliseconds. And then digital write 13 low, turn off. And then again, wait for 1000 milliseconds. So here is what happened on the actual hardware. This LED is turning on, waiting 1 second, and turning off again. I can go to change the delay value, and for example, now I'm reprogramming. You can see the transmission LED it was blinking, and here you see the LED now is turned on and off only for 200 milliseconds, and I can put whatever I want. I can change to other values. For example, let's see now. Now it's transmitting the new code, and you see now I made it much faster. And this is, I find this very exciting, because with a few commands and no expertise at all, you made it a LED blinking. Now I made it 2 seconds on, 2 seconds on, off. And it takes the electricity directly from the USB, so you don't need to use the breadboard power supply as I used. I mean, because I bought it and I feel pretty. Yeah, so it's very easy to use, and there is no limit.